Today we're going to look at how to evaluate rational exponents. Rational numbers are fractions, so we are going to have exponents that are fractions. Look at how to evaluate those. Now, it would probably be to your best interest, since this is probably a new lesson, for you to take as thorough of notes as you can so that when you look back at this, you can remember in case you forget. Here we have 125 to the 1/3 power. Before we start that, let's just back up for a moment and do a little lesson on radicals. If you see this on a piece of paper, you would probably say to me that that says the square root of 25. And a lot of people call this a square root sign. What you may not have known is that when you have that, there's actually an invisible 2 right here. And it's understood to be a square root when there's not a number that's located right here. And we know that that means that what number multiplies times itself twice to get 25. So the square root of 25 is 5. This sign right here is called a radical sign. And if there is not a number located right here, it's an understood 2, which is the square root. But you are also going to see a 3 right there. That means the cubed root of a number. That means what number multiplies times itself 3 times to get that number. You're going to see the 4th root, what number multiplies times itself 4 times, 5th root, and so forth. So that's just a little background today because we're going to be having some cubed roots and 4th roots. Up here we have 125 to the 1/3 power. When your exponent is a fraction, the denominator becomes what we call the root. Okay, so this is the root. And I have a little visual of roots there to remind you that that's the root. That means that is the number. We're going to rewrite these 3 numbers and rewrite it with a radical sign. So the 3, or the denominator, becomes the root. The base is the number that goes under the radical sign. We're going to put that in parentheses, and the numerator of the fraction becomes the exponent that is outside. So if you look at this, all we did was take the numbers that were up here and we rewrote them with a radical sign. Okay? So review. The denominator, the bottom number, becomes the root. The base becomes the number under, we call it the radicand, the number under the radical sign. And the numerator becomes the exponent. Now, how do we evaluate this? Well, we always have learned to solve PEMDAS, parentheses first. So the first thing we're going to do is ask ourselves the cubed root of 125. What number multiplies times itself 3 times to get 125? That would happen to be 5. So now we have 5 raised to the 1st power, which is just 5. So it looks kind of scary, but once you learn how to rewrite these and evaluate them, they're actually pretty easy. Here we have 81 to the 1/4 power. Again, we're going to rewrite this with a radical sign. The denominator, the 4, becomes the root. So we want the 4th root of, the base becomes our radicand, the number under the radical sign. So what that means is what number multiplies times itself 4 times to get 81. Then we're going to take the numerator and raise it to the 1st power. Once we rewrite it, it's pretty easy to evaluate. You can take your calculator and figure it out, but the 4th root is just 3, and 3 raised to the 1st power is 3. Here's the first time that we've had a numerator that's something other than 1. Works exactly the same way. We look up here, we find the root, or the denominator. So we want the cubed root of 216. We're going to put that in parentheses, but this time we're going to square it. According to PEMDAS, we always evaluate the parentheses first. So first we want to find out what number multiplies times itself 3 times to get 216, and then we're going to square it. So what number multiplies times itself 3 times? It would be 6, and then we take 6 and we square it, and we get 36. Okay, this works exactly the same way. It looks a little scarier because you have 2 of them, but we're going to follow our order of operations. First, we're going to rewrite the rational exponents with a radical sign. So in 64 to the 1/6 power, we have the 6th root of 64, and then we're going to raise that to the 1st power. Then we're going to add that to the square root of 25 raised to the 1st power. So all we did was rewrite them with radical signs. Now, if we ask ourselves what number multiplies times itself 6 times to get 64, that would be 2. So we have 2 raised to the 1st power. What is the square root of 25? 5 raised to the 1st power is 5. So we just have 2 plus 5 equals 7. So it looks scary, but if you just take it step by step, we got this. Now here we have some bases already written under the radical sign, and they have exponents attached to them. So we have the cubed root of x to the 9th power and y cubed. So again, we have to ask ourselves, we can first break this into 2 parts. The cubed root of x to the 9th power and the cubed root of y to the 3rd power. In this first one, what multiplies times itself 3 times to get x to the 9th power? Well, I'm going to erase this so you can see this. If you have x cubed times x cubed times x cubed, that equals x to the 9th power. So if you look up here, all you had to do with the exponents was actually divide them. X to the 9th power, the cubed root of that would be x to the 3rd power. Then if you ask yourself, we have the cubed root of y cubed. What multiplies times itself 3 times to get y cubed? Well, y times y times y equals y cubed. So you multiplied y times itself 3 times, so you just have y. So your final answer is simply x cubed y. Again, if you look up here, all you have to do is divide your exponents. You went 9 divided by 3 is 3, and then 3 divided by 3 is 1. Now they're going to start looking a little scarier here, but you know all of the steps that are involved here. The first step, if you look back at this, is the power of products that we learned. Here we have 2 bases, an x and a y inside parentheses, with an exponent raised to an exponent. We have learned that when we do that, we have to distribute the exponent to each one of these. So we have x squared raised to the 4th power. We have learned that you have to multiply those exponents, so that would be x to the 8th power. And then we have y to the 1/2 power raised to the 4th power. Again, you multiply those. Well, half of 4 is 2, so that's just y squared. And then we have the cubed root of y to the 3rd power. We just learned that when we have that, we just divide the exponents. So 3 divided by 3 is 1. So we have times y to the 1st power. Now we can multiply. So our final answer would be x squared y cubed. I'm going to look at a couple more examples on the assignment that you have for today. Let's look down here, for example, at number 10. Here's a good place to start. It looks pretty scary because you've got a lot of big numbers. But again, we have an exponent that is a fraction, so we're going to rewrite it with a radical sign. The denominator becomes the root, so we have the cubed root of 343, and then we are going to square it. Then we're multiplying that times, here's the root, the 5th root of 32, and then we're going to square that number. Now, according to order of operations, we have to do our parentheses and exponents first. The multiplication is actually going to be the last step. So first we find the cubed root of 343 and we square it. The cubed root, or what number multiplies times itself 3 times, would be 7. And 7 squared is 49. We're going to multiply that times what is the fifth root of 32. That happens to be 2. And 2 squared is 4. So in our final answer, we have 49 times 4, which is 196. In the section below that, you're just plugging in numbers. For example, let's look at number 14. Here you have m to the 3/5 power divided by 8. So if we plug in 32 to m, you have 32 to the 3/5 power divided by 8. We're going to rewrite this with a radical sign. So we have the fifth root of 32, and then we're going to cube it. And the very last step is we're going to divide that by 8. The fifth root of 32 is 2. And when you go 2 times 2 times 2, that equals 8. So we have 8 divided by 8, which is simply 1. It looks scary, but you're just plugging in numbers and following your order of operations. I'll see what you can do with the rest of that assignment. Good luck.